For our caffeine experiment today, you will first add the sodium carbonate to your water. You will then add the tea bags. Make sure that you have followed the instructions and you had removed the labels and the stapler from the tea bags before weighing them out. The boiling stick will serve as the nucleation site and not let your water give you hot splashes. Now, the first step that you are doing is the solid liquid extraction. What does that mean? It means that at low temperature or at room temperature, caffeine has a very low solubility in water. As the temperatures increase, this solubility also increases. And at one point, when you see roaring bubbles in your beaker and the temperature is almost 100 degrees Celsius, the boiling point of water, the caffeine solubility dramatically increases. And the caffeine from solid tea leaves goes into the water liquid. So from solid, it has now been extracted to the liquid. After you have extracted out the caffeine into water layer and your beaker has cooled to room temperature, you will gently take out these tea bags, squeeze them very gently, and then throw them away in the trash. A black tarry liquid will be left behind, which will be containing your caffeine and other ingredients. You will take 2 centrifuge tubes and put a little bit of water in them, cap them, and invert those centrifuge tubes to check for leaks. You will then throw away that water and you have to fill half of this amount from this beaker in one tube and the other half in the other tube. Make sure both the tubes have same level of solution. A point to note here is that your solution, this tea solution, should be at room temperature because we are going to add dichloromethane in it. If this solution is warm, the dichloromethylene that we are going to add has a boiling point of 40 degrees Celsius. As soon as you will add the dichloromethane in this warm solution, it will evaporate away. So this is a very important precaution that you have to take. In both of these tubes, you will dispense 3 milliliters of your dichloromethane. You will cap it, gently shake it, open the cap to vent it, cap it back, and then centrifuge. When you centrifuge, make sure the amounts in both the liquids is exactly same, and you place your centrifuge tubes in opposite sockets of the centrifuge. Do not stop the centrifuge by poking fingers in those sockets, okay? Otherwise, one of your fingers may be lost doing so. Once you have centrifuged, you will take your tubes out. You will see the 2 difference in the layers. The dichloromethylene being heavier or denser will be at the bottom and your aqueous layer will be at the top. Why did we add dichloromethylene? The reason is at 25 degrees Celsius or room temperature, as we had discussed earlier, caffeine has a low solubility in water. But at the same temperature, around 20 to 25 degrees Celsius, caffeine has a higher solubility in dichloromethylene. And this is what we are going to use for our liquid extraction. From the aqueous layer, from the water layer of liquid to the dichloromethylene layer, which is also liquid, we can extract out caffeine because of favorable partition coefficient. So both of these, solid liquid extraction and liquid extraction, have different reasons for being applicable. What is partition coefficient or distribution coefficient, as we also call it? It is just the ratio of solubility of a compound in the organic solvent, in this case methylene dichloride, divided by the solubility of that same compound at the same temperature in water. So if you divide 8.45 by 2.26, you will get 4 point something, which is a larger or favorable partition coefficient. This helps extract compound from the water to the other solvent, which is the organic solvent, dichloromethylene in this case. Now, usually when you will boil your tea, you do not add sodium carbonate. Why are we adding sodium carbonate? So there are a few of these important reasons that we add sodium carbonate for. First, it acts as a base and it helps deprotonate the phenolic OH of the tannins. Now, tannins are another ingredient found in the tea leaves, which we do not want in water. Tannins in general are soluble in water. However, they have low solubility in dichloromethylene. Another reason that we add sodium carbonate is so that caffeine can stay as a free base and does not react with any other acids. For example, the phenolic OH of the tannins. There is another sodium salt that we are going to use in today's experiment, which is sodium sulfate. What is the role of sodium sulfate? It is a drying agent. It will first try to absorb the water molecules from your organic material, if it is liquid. And if you have added enough sodium sulfate that it has absorbed all your water, it will then start to absorb your organic liquid. So you have to add just enough sodium sulfate. Just like we did for the recrystallizations, where I provided you with different situations or conditions, you will be dealing with different situations and conditions for your caffeine lab also, based on which you will have to interpret what happens to percent recovery and what happens to purity. For example, excess of sodium sulfate was added. Now, sodium sulfate has no role to play in the terms of purity. It only absorbs the solvent. But once the solvent has been absorbed and you add excess of sodium sulfate, your recovery will decrease because sodium sulfate starts to absorb your organic compound also. And so, when you have collected your aqueous layer and the dichloromethylene layer, you need to remember that it is in your dichloromethylene layer where your desired caffeine compound is. Using a pipette, a fresh pipette, you would take out this lower layer and place in a 50 ml Erlenmeyer flask. You will repeat this extraction one more time and then use the same pipette to extract out the lower layers of dichloromethylene. Once you have collected or you have done your steps A, B, and C again, you will use your pipette to remove excess water droplets, which may collect at the top. So they may appear as dark, oily material floating on top of your Erlenmeyer flask. Once you have removed from the top as much of that black liquid, now you will add sodium sulfate. How much sodium sulfate you have to add? You will add in small pinches. You will add a little bit of sodium sulfate, swirl it. When you swirl it, you will see the clumps form and some fine powder also. When you swirl, the clumps and that fine powder swirl with your flow, the motion of this liquid, you know that you have added enough. You cannot break the clumps. So be wary of that. At this point, let this solution sit for about 5 to 10 minutes. Meanwhile, you should prepare your TLC chamber.